Now in this video we will learn about basic properties of a circle which is used in circle geometry. Whenever they will tell you you have to solve these circle related problems, then these properties they will be used, and also the converse of these properties, it is also true. So the first property which we will discuss here is saying that the angle in a semicircle is a right angle. So I have drawn a circle with my hand without anything, so it's not a proper circle, but I will show you. The angle in a semicircle is a right angle. If I will draw a circle, then what will be the semicircle? This is the center of the circle, and if I will cut it into two halves, right, then this is semicircle and this part is also a semicircle. So the property is saying that the angle in a semicircle, this is a semicircle, right, cut the circle into two parts, then this angle is a right angle. For example, there is a point and I will join this point with this and with this point, then the angle which is made, this angle is of 90 degree. So this is the first property. It can be used and you have to remember this one property. And the converse of this property is that if we have a right angle, then this right angle will be the one angle of a semicircle, right? So this is the converse of this property, meaning that if the angle in a semicircle starting, and this is a right angle, and the converse is that right angle, and this right angle is also angle in a semicircle. So this is the converse of this property, and both of these properties they can be applied when they have given to you different problems in which circle is involved, right? This is the first property. And what is the second property? Second property show that any perpendicular from the center of a circle to a chord bisects the chord. What is the meaning of chord? First of all, you have to know about what is a chord. If we have a circle, I will draw a circle like that, right? This is not a circle, but suppose this is a circle. Then two points, if you will join two points in the circle, but the line which is joining the two points on the circle, this is called the chord, but this line is not passing through the center of the circle. Whatever line, you can see that this is not passing through the center of the circle. Two points, join them with the line, right? This point and this point, join them with the line, and this line is not passing through the center of the circle. These are called, all of these are called chords of a circle, right? All of these are called chords of a circle. So the second property is saying that the perpendicular from the center of the circle, if you will draw up a perpendicular from the center of the circle, and it will bisect the chord. Bisects mean it will cut your line into two equal parts. This is the called bisect or bisector of a line. You will remember this by the word bisect. Bi mean two parts, sect mean sections, right? So bisector or bisect mean you have to divide it into two equal parts. So the property is saying the perpendicular from the center of a circle, right, to the chord, the perpendicular should be on the chord, and that perpendicular bisects the chord, right? I will read it again. The perpendicular from the center of a circle to a chord bisect the chord. So in this definition you can understand, this is the chord, this is the perpendicular from the center of the circle. So the chord is divided into two equal parts. These two lines show that this line length and this line length, though both are equal, right? Or you can see here, if I will draw a chord here, right, and I will draw up a perpendicular from the center of the circle like that, then this is perpendicular and the chord will be divided into two equal parts. This length and this length both have same length, right? So the chord is divided into, bisect into two equal parts, or you can say chord is divided into two equal parts, or you can use the word bisect, right? Both have same meaning. No, I will show you the converse of this property. The converse will be like that: the chord bisects, if the chord bisects to a point from a center of the circle, then this line is a perpendicular. This will be converse of this property, right? And the third property is saying that tangent to a circle at a point is perpendicular to the radius through that point. Now, what is the tangent? I have explained you what is a chord. Any two points on the circle, you will join them and then you will get a chord. Now, what is the tangent to a circle? If I will take any point on the circle, then the line which is passing through that point touch the circle at one point, and that tangent to the circle that is perpendicular to the center of the circle. This is the definition. This is the property. I will read it for you again. The tangent, this is the tangent to a circle. This is the tangent to a circle at a point. Always remember, tangent to a circle is always on a one point. If somebody is saying draw a tangent to a circle, just take a point on the circle and you will draw a line passing through that point. This line is called the tangent to a circle, right? So this is the tangent to a circle, this is a tangent to a circle, but at a point. This is a point, this is the point. So you have to use this definition. If this is a point, I will draw the tangent, then tangent line will be like that. It will touch the circle only at one point. You will take a ball, a football, and you will put a pencil on that ball. You will see that this pencil will touch the circle at one point only. So this pencil is called the tangent. At what point it is touches, this pencil is called tangent. The point where it touches the point, the tangent to a circle at a point. So this is perpendicular to the radius of the circle through that point, right? Through that point, not here, not here, not here, only this point. So from here this will be perpendicular. This is the definition. And the converse of this definition is that we will do it converse. Through any point radius, through any points, it is perpendicular to the tangent of the circle, right? You can do it converse this definition. So in whenever you will have to solve the circle related problems, these definitions will be applied. Keep in mind this definition and also the converse of these definition. So basically there will be 6 properties. First property and its converse, second property and its converse, third property and its converse. So basically we have these 6 properties.